Alright, so this is the second lesson for the chapter Discrete Random Variable. So today we'll be continue on for the learning outcome that we actually proceed last lesson, which is in the last lesson you already learned that how to find the probability distribution and how to create a table. Okay, so for today we are going to the second part of this learning outcome, which is how to calculate the expectation for the random variable and how to calculate the variance. So today's lesson will be pretty short. When you look through the outcome, you can realize that it's only 4 examples because it's just about formula, and I do not want to lengthen the videos by putting on a lot of repeating example and so on. So that's why today's lesson will be pretty short. I hope that you can take your own time to go through the past year paper and so on, so that it will be more effective, I think. Okay, so alright, so let's do some recap. In the last lesson, you learned what is random variable and what is a discrete random variable. So basically, the variable is some number that actually will come out as a result in an experiment. Okay, so when we talk about random variable, then we have two types as we have learned. So you have one discrete and one continuous. So in this chapter, we are only focusing on the discrete part, which means all your outcome is like an exact value. Okay, then you learn how to find the probability distribution, how to list down all the possible value of x, and how to find the probability of every x. Then you also already know that all your probability should be in the range between 0 to 1, and then the sum of all your probability should be equals to 1. So this is just like a recap from last lesson. Okay, so for today we are going to see two things. So the first one is called expectation of a discrete random variable. The second one is called as variance of a discrete random variable. So in short, it's just like how to find the expectation and how to find the variance. Okay, so you should not be is something that you have heard before. The word expectation might be something new for you, but expectation basically means mean. Okay, then variance, you already heard about this when we learned about the representation of data in our chapter 1. Okay, so it's not something that very strange for you, so you should be quite familiar with the term and so on. It's just that we try to use different formula and they represent, or they are going to interpret, analysis different thing for discrete random variable. Okay, so we'll go through it together. Okay, so alright, so the introduction part you can read yourself. So it's basically like when you have a bigger number of your probability, the likelihood for the event to happen will become higher. And then when you carry out an experiment, basically you can produce a frequency distribution like what we have learned in previous chapter, and this distribution also have a mean, okay, and also a variance. Okay, so now we are going to learn how do we find that. Okay, so first thing, so the mean of a discrete random variable is referred to its expectation and is written as ex. Okay, so if you still remember, in statistics we will always write it in x bar. Okay, if you still remember, for last time we will every time when we have mean, right, we actually write in this term. But for discrete random variable, we don't put the symbol as like this, we use ex. So you just remember, expectation means mean. Okay, just like that. Okay, now suppose that we have a biased spinner that we can score 0, 1, 2, 3 when you spin the spinner. Okay, so now this is the probability distribution. So meaning for you to score a 0 mark, it will be 0.1. And then for 1, it will be 0.3 and so on. Then you can realize that all the probability, when you add up together, you will get 1. Okay, so now this is the probability. Let's say if we carry out this experiment with 100 times, what is the expected frequency for every score? Okay, so the probability for the random variable 0 to happen is 0.1. So if the probability is 0.1 and your sample space is number of trial that you actually make is 100. So out from 100 trial, how many of your trial you will get a 0? Okay, so how you will do that? So if you still remember, in probability, we learned that probability for A to happen is basically equals to number of A to happen, then divide by your number of sample space, right? So when you want to find out your NA, basically you are using your probability to times your sample space number, which is the total trial that you actually made. So in this case, meaning that if you want to find out what is the expected frequency for x equals to 0, then you will use 0.1 times 100. Okay? So meaning that when you actually try out this experiment for 100 times, you will expect to get a 10. Okay? Of course, this number, like for example, we say that when we toss a coin, the probability for we to get a head and a tail is 1/2, right? But when we really do the experiment, it's just a theoretical meaning like it's what we have expected. But when we really do it in the real life, it might not be the case, meaning because there will be some like mistake, or like there will be some thing like, because we do it like randomly, so we cannot expect that we will get exactly 5 head and 5 tail when we toss the coin for 10 times. That's what it means. So you just remember, for this expected is like in theoretical, in a logical condition. Okay, this is what we expect to get, but this might not be the real one when we really carry out the experiment. Okay, so for 1, the probability for x equals to 1 to happen is 0.3. So 0.3 times 100. So you expect, or like in a very rational condition, then you should be able to get 30 times score 1. Okay, so the same thing for 2, you will use 0.4 to times 100, which you expect to get 40 times of 2. Okay, for 3, then you have 0.2 times 100, which you expect to get 20 times of 3. Is that okay? So this is how you find the expected frequency. Okay, now let's move on. So we already learned that what is the formula for the mean that we have learned previously. So we will use the sum of f times the x. Okay, so we write down the formula for us to find the mean. Then normally we will use our data to times every corresponding frequency, then divide by the total frequency, right? This is what we have learned in chapter 1. Okay, so now this is the table, then we try to times them together. This is the frequency, this is the S. So meaning I have 0 times 10, okay, and then plus 1 times 30. Okay, I hope that you know what I'm doing here. So it's basically using every x to times the f, and then plus 2 times 40, and then also plus 3 times 20. Okay, this is how I'll find the mean. Then I will divide the whole thing by the total number of frequency, meaning 10 plus 30 plus 40 plus 20. Okay, so when we plus together, and we will get an answer like 170 divided by 100, which gives me an answer of 1.7. So this is the mean that we can get from the table when we try to assume that we try to do an experiment with 100 times trial. Okay, but in reality, it's very hard for us to be like, because when we look at the condition, we try to look at it in general. So we cannot have every time like assume a number. But what you can realize here for this question is that, you see, how do I get all these numbers like 10, 30, 40, and 20? Actually, I times everything with 100, right? And I divide by 100. So imagine for all the case here, I try to divide by 100. So meaning 100 divided by 100, then every of this term I used to divide by 100, meaning that I don't times them together. Then what do you get? You get exactly back to the probability. So let's say we try to check and see when we try to use probability instead of the frequency that we have done. Okay, so let's see. So we are changing our f, meaning our frequency, to become the probability. So sum of x times p divided by sum of p. So what do you get? Okay, so we refer back the first table that we have here. Okay, so every x you are going to times the corresponding probability, the respective probability. So 0 times 0.1 and plus 1 times 0.3 plus 2 times 0.4 plus 3 times 0.2, and after that you divide by the total of the frequency, which you use 0.1 plus 0.3 plus 0.4 plus 0.2. Okay, so when you times them together and plus them together, you will get 1.7 divided by 1 equals to 1.7. You can realize that I can actually get the exact same answer as when I convert it into frequency. Because what happened is when I want to find out what is the expected frequency, I times everything with 100. That means my total frequency will be times 100 also. So when I divide by 100, I actually get back the original number. So from what you can realize here, right, the sum of the probability, because of this condition or like this rule that we learned before, that all the sum of the probability in the probability distribution, the sum must be equals to 1. So this is how you get 1, and no matter which probability distribution that you are doing, you always get a 1. So since the sum of the probability is equals to 1, meaning that the mean of the expected value is actually you left with the sum of the x, meaning what is the possible value for your probability distribution, what is the possible outcome for your random variable, then you times with your probability. So you do not need to divide by the sum of p, because the sum of p is always 1. So this is how we get to our first formula, which is the expectation of x, which is the mean of the probability distribution is equals to sum of x times p. So x is the value of the discrete random variable and p is the corresponding probability. So it's basically by using your distribution table, you use every value of your discrete random variable to times the respective probability, then you will get the answer. Alright, okay, so that is for expectation part. So you just remember whenever they ask about the mean or the expected value, they actually means the same thing. Okay, so the second one, let's move on to variance. So you also learn this also in chapter 1, which is what variance means is like if it gives you a measurement about like how far all your data separated from the mean. So it's the same thing like for this one. Then for discrete random variable x, the variance actually give a measure of how spread your data, your value around the mean, which is the expectation of x that you have found just now. Okay, so I'm not going to do a lot of like the derivation part for the formula. So I'm just going to use a very simple concept by using the formula of variance that we learned in chapter 1. So if you still remember, the formula for us to find the variance is like using the sum of x squared, you times the respective f, then you divide by the sum of x, then you minus the mean square. So I hope that you still remember this. So it's the same thing. You can see that for mean, right? So instead of using f, we are using p to substitute the f. So we do the same thing for the f, we use p to substitute. And then for the mean part, so for statistic, for data representation, we use this symbol. But in discrete random variable, we use expectation. So it's the same thing, we try to change the mean symbol to expectation. So this is how we get the second formula. And the same thing like just now, the sum of probability is always equals to 1. So we have the second formula here, which the variance of the probability distribution will be equals to the sum of x squared times the probability, then you minus mean square. Okay, so the x and the p means the same thing and ex means the mean. Okay, so don't worry, we will try to go through the example together and how to use this formula. So in your exam, right, the formula will be given as below. So you can like look at this and then you just remember like what is the thing that you must know that won't be stated in your exam is like they won't be telling you that EX means the mean. So you need to know yourself that EX, the expectation of X, basically is the mean. So the variance X you should not have any problem, but you just need to understand what is X, what is P, and what is EX, and so on. So this is the formula that will be given in your exam. Okay, so now we try to look at the example together, like how to use the two formula here. Okay, so we'll put this aside as a reference. So when you do your exercise, you also can try to put the formula aside, or I think for statistic, right, it will be helpful also, like every time in the handout, I will give you this part. So if you still remember for chapter 1, for the mean, for the variance, I also try to give you how the formula look like in your exam. So maybe you can try out, like take one piece of paper. So every time when you have this area, right, you try to jot down in your paper, then you have a list of formula that you know that will be given in your exam look like this. So whenever you do your exercise and so on, you can refer to your formula sheet as like it give you an idea of how your exam, or when you answer question, how will the condition, how will the situation look like. Okay, so now let's move on to number 1. Okay, so given the probability distribution of X as the table here, so find the expectation, the variance, and the standard deviation. So it's just basically I want to show you guys how to use the formula for the number 1. So it's a pretty easy question. Okay, so how to find the expectation? So let's go back to the formula. So expectation of X will be equals to the sum of every X times the corresponding P. Okay, so you have the table already, then now we can try to substitute the number that we have here. Okay, so basically the first one, I have 0 times the respective probability, which is 1 over 12, plus the second one, 5 times 3 over 12, okay, and then plus 15, 5 over 12, and then plus 20 times 3 over 12. Okay, so yeah, this only, you do not need to divide by, I mean, if you write it, you actually got the same answer also, like divide by the whole probability. When you add up together, then you get a 1. So like anything divided by the 1, you get the original number, right? So it's totally fine. Okay, so when you add up and when you times them together and you add up your answer, you should be getting 12.5. Okay, so just like that, very easy. Just follow the formula in the sheet. Okay, so the second one, find the variance. So let's write down the formula also. The variance for X will be equals to sum of X squared times the P, and then minus EX. Okay, so now let's try to substitute the number that we have here. So you see all the value of your discrete random variable, you square it. So 0 square times the probability, and then plus 5 square, you times the probability, plus 15 square times the probability, and plus 20 square, same thing, times the probability. Okay, everything here you will add up together. Alright, the sum of, okay, then minus your mean square. So the mean, the expectation that we have find here is 12.5 square. Okay, so you use your calculator to get your answer, and you will be getting 200 minus 156.25, which gives you 43.75. Okay, so as simple like that. Okay, now move on to the standard deviation. So when you want to find the standard deviation, you still remember what is the relationship between variance and standard deviation is that you need to square root your variance. So standard deviation, square root 43.75. So this one you will get your answer 6.61 in 3 significant figure. Okay, simple. Alright, let's go to number 2. Okay, X is a discrete random variable with probability distribution below. So given that's the expectation or the mean, calculate the value of X and B, and calculate the variance of X and standard deviation of X. So now you see you have two variables here. So if you want to solve two variables, right, that means that you will need two equations. So you can imagine that we will need a simultaneous equation in this question. Okay, so then what is the two thing, or what is the two known concept, or like two number that you already know that can help you to get this answer? So the first one is given the expectation is 2.6. Then the other one is from the concept that we learned previously. You know that the sum of all the probability, when they add up together, they should get a total of 1. Okay, so let's try to do that. Okay, so the first one, maybe let us do the sum first, because that will be much more easier. Okay, the sum for probability when the random variable equals to the value of x, you should be able to get 1. Okay, so meaning that a plus 0.2 plus b plus 0.2, you should be able to get 1. Okay, so let's try to do this. A equals to 0.2, 0.2, 0.4. So when you move it there, you get 0.6, and you move b over there. So you have 0.6 minus b. So this is your first equation. Okay, then move on for the second equation that you will need to do. The ex equals to 2.6. So as ex, the expectation of x equals to 2.6, what does that mean? That means that the sum of your x times p, you should be able to get 2.6. Okay, so let's try to expand it. So 1 times a plus 2 times 0.2 plus 3b plus 4 times 0.2 will be equals to 2.6. Okay, so I don't have enough space, so you try to expand yourself here. I'm just going to like write down. So which 1a plus 0.4 plus 3b plus 0.8 equals to 2.6, sorry. So when I move everything over here, I'll get my second equation, which is a equals to 1.4 minus 3b. Okay, then you can solve your equation. So meaning that 0.6 minus b will be equals to 1.4 minus 3b. Then I'll be able to get my a and b. Okay, so you try to solve it yourself. I'm writing the last number because I don't have enough space here. So I think when you use your pen, you should be able to get a bigger space than this. Okay, so you should be able to get a equals to 0.2 and your b is 0.4. Alright, okay, so this is how you find your equation for a and b. So settle for a. Okay, b, find the variance. So since you already have the expectation of the number, then you have find out your a is basically 0.2 and your b is 0.4. Then now you can carry on with the calculation. So variance for x will be equals to sum of x squared times p minus ex square. Okay, so it will be equals to 1 squared times 0.2 plus 2 squared times 0.2 plus 3 squared times 0.4 plus 4 squared times 0.2, and I minus my mean here, which is 2.6. Okay, so when I continue to do it, I will get 7.8 minus 6.76, which gives me 1.04. Okay, so for standard deviation, you are going to do square root. So standard deviation for x, it will be equals to square root 1.04, which will gives you an answer of 1.02. Okay, so that's number 2. Okay, that's pretty easy also. So yeah, okay, so let's move on for the next one. Okay, number 3. So x is a random variable with the proper probability distribution given. Show that k is 0.2 and calculate the expectation. Okay, this is much more easier than the question just now, because I think that you actually learned how to solve this in the previous lesson also. Okay, so try to use the concept or the characteristic that the sum of your probability of x must be equals to 1. Okay, so 5k plus 2k plus k plus 2k, you will be getting 1. So 10k equals to 1. So k will be equals to 0.1. Okay, so you already shown. Okay, maybe you can write it here. So question asks you to find the expectation for x. So ex will be equals to sum of x times p. Okay, so 1 times 5k meaning that 0.5, or if you want to write a full one, then you can write it 5 times k, right? So 0.1, then plus 2 times 0.1 plus 3, only k, so 0.1 plus 4, 2 times 0.1. Okay, so you expand everything, then you will be getting 5, 0.5, 0.4, 0.3 and 0.8. So you should be getting 2. Okay, so that's expectation. Okay, number 4. So let's try to see if it's given a question like the modeling also, then how are you going to find the expectation and variance. So you can realize that it's basically the same thing, like asking is just like this is further analysis for the probability distribution that you actually learned in the last lesson. So you can see that every question, right, you still have something to do with your probability distribution, because that is like the basic of it. So everything that you learn like for the expectation and the variance is like built on the probability distribution. Okay, so number 4. In a bag there are 4 red towers and 3 yellow towers. Towers are drawn at random from a bag, one after another without replacement until a red tower is obtained. I'll change in your handout. Okay, if x is the total number of towers drawn from the bag, obtain the probability distribution of x. So find out the expectation of x and the variance. Okay, so before you find out the expectation and the variance, so from the experience that we dealing with this formula, right, you will need your every of your possible outcome for x, and you need to times the corresponding of the probability. So we don't have this formula, so we don't have all the information, so meaning that you need to find out yourself. So that's why the question asks you to obtain the probability distribution of x first. Okay, so now we need to try to find out the we need to create the table like yesterday, like Wednesday. Alright, so let's try to assign first. Write down again what is the x mean. Okay, so for this question, x actually mean the total number of towers drawn from the bag. Okay, so the same thing, what is the possible outcome for x? So you want to find out the total number of towers drawn from the bag. So how do you actually decide that? So you can see the towers are drawn at random, one after another without replacement until a red tower is obtained. So what is the possible outcome? It cannot be 0, right? Because when you draw 0, how can you get a red tower? So it must be the first one. Maybe the first one you get the red tower already. Or maybe if you don't get it for the first one, maybe you can get it in the second one. Or maybe the first 2 you also get a yellow, then maybe the third time you can get a red one. Okay, then you stop already. Then after that, maybe for the 3 times at first you will get all 3 yellow tower. So you might need to draw for the 4th time. Okay, so when you reach the 4th time, is that a possible that you already draw like 3 times before and the 4th time that you still didn't get a red tower? It's impossible, because this bag has 3 yellow tower and 4 red tower. So if for the first 3 times you already get the yellow color, meaning what is left in your bag is all red towers, right? So the maximum or the highest x that you will have here is up to 4, because until the 4th tower, I should be able to get at least 1 red tower already. Okay, so that is our possible outcome for the random variable x here. So now let's try to find the corresponding probability. Okay, so for this question, I am going to show you 2 ways also, like the combination and the tree diagram. So for this question, actually tree diagram will be much more easier because you have only 2 variables here, and combination is like, actually the idea is the same, but then for combination normally we use it in the in the condition that, like for example, if I'm going to pick 3 together, so because one after another one, there's no point that you want to do combination, because it's just like for every combination you're going to pick one, you're going to pick one again, you're going to pick one again. Okay, so I'm going to show you 2 so you can compare yourself, but you can try to write both in your example also. Okay, so probability for me to draw only 1. Okay, what does that mean? Meaning that for the first tower that I drawn in the back, I actually get a red tower. That's why I stop, right? Yeah, then after that, meaning that what is the probability? Meaning the probability will be like out from the 7, the sample space I have, which is 7 towers, I will be able to get the red tower, which means 4/7. Okay, as simple like that. Okay, 4/7 meaning that I get a red tower, then I stop already, meaning that I only draw 1. Okay, so if you want to use the combination, then what will you write? So it's the same thing. So the first one, the total is the one that without any restriction, right? So under 7, you are going to pick 1. Then after that, you need to get a red tower, so that's why 4C1, which gives you the same answer, which is 4/7 also. Alright, okay, so let's move on for 2. So for me to get x equals to 2. So what does that mean? Meaning the first time you are going to get a yellow tower, so that's why you are continuing. So for this case, right, you see, you are going to have only the probability that first time you get a yellow, second one you get a red. It cannot be like you get a red, then after that yellow, because if you get a red at first, then you are not going to continue anymore. So that's why the first time you should get a yellow tower, which the probability is 3/7. I get a yellow already, meaning that now inside the bag, I only have 6 left. And then I need to get 1 out of the 4 towers, so that's why 4/6. So which gives me 12/42, which is divided by 6, I should be able to get 2/7. Okay, now let's see combination. Okay, so the same thing, but something that you need to be in mind for this one is that you remember normally for the denominator part, we'll try to do the combination without restriction 1. So meaning for this one, you can see that you actually get 2 out of 2 towers. So maybe you will think that you want to do the total sample space, you will try to do 7C2. Okay, but that is wrong in this case, because why? You cannot like select 2 at one time, because you need to check like for the first time whether you get a red tower or not. So you cannot do it like out of the 7 you are going to pick 2. It's going to be different situation. So that's why if you want to do that, then what you should do, so meaning the first one you must get a yellow tower, so meaning it will be 3C1. Out of the 3 yellow color, I'm going to pick 1. So divide by, because I only pick 1, right? So that's why 7C1. And then I times with the second time, I need to get a red tower, so that's why 4C1. And I divide by, now how many do I left? I left 6. How many do I pick? I need to pick 1, so that's why 6C1. Which gives me exact the same thing when I do 3/7 times 4/6. Which is the same thing, 2/7. Is that okay? So you cannot do 3C1 times 4C1 divided by 7C2, because if you do like that, meaning that you are assuming you pick them together. So that's going to be different than you pick it separately. Okay, so now let's move on for px equals to 3. Okay, so what happened for this one? So meaning that you must get the first one yellow, the second one also yellow, then only by doing that you can continue for the third time. So meaning that the first one I get is 3.7. I times the second times, I will get 2 out of 6. Okay, I already picked 1 yellow for the first time, so I left with 2 yellow and my total becomes 6 now. And then I times the third time, I should get a red tower. So that's why 4 over how many I have? 5. Okay, so for this one I'll be getting 24 divided by 42 times 5, which gives me 210. Okay, so when I simplify this, I will be able to get 4/35. So same thing here, you cannot do 7C3 because you are not going to combine them together and pick it at one shot. So if you want to do this, then it will be 3C1 times 7C1, then times 2C1 times 6C1, then the third time it will be out of the 4, you are going to pick 1 at 5C1, which gives you exact same answer. Okay, so let's move on for the last one. Probability for x equals to 4. Okay, so if you do it 4 times, meaning that the first 3 times you get all the yellow tower, and for the 4th time you should be able to get one of the red tower already. So that's why 3 over 7, then you left with 2, total becomes 6, and then times 1 over 5. You left with only one yellow tower, and then the total becomes 5 now, and then times with. So what's the last one? So the last one is the total number, how many you have in the back now, 4. So how many red tower do you have? 4. So you can see 4 over 4 meaning 1. So 1 meaning the probability for the event certainly will happen. So is that correct? Yes. Because I already picked all the yellow tower. So in the back I only left with red tower. So I know 100% that when I pick it up, I should be able to get the red tower now. So that's why the probability is 1. So when I times them together, then I'll be getting 24 divided by 840, which gives me an answer of 1 over 35. Okay, so it's the same thing. If you want to do combination, then you are going to add something here. Yeah. You try to write yourself, can you? So here you will add one more. So this is going to be exactly the same. Then after that, it will be 1C1 times 5C1, and then times with 4C1, then divide by 4C1. Okay, so you get 4 over 4 lah, then you will be able to get the exactly same thing also. Okay, so now we can try to build the table. So x, okay, px equals to x. Okay, 1, 2, 3, 4. So I have 4 over 7, 2 over 7, 4 over 35, and 1 over 35. Okay, try to build the table yourself using your ruler and so on. So I'm just going to oh no, it's okay, as long as you see it. Okay, alright, so you got this table already. Now we can proceed to our question already. Okay, so for A, you need to find the expectation. So same thing, just use your formula. Expectation of x equals to sum of x times p. So it will be 1 times 4 over 7. Oh, one thing, sorry. After you build this table or after you find everything, right, please check out with your calculator whether you get an answer for, whether you get an answer of the sum of the probability equals to 1 or not. So if you are not getting that, then you should check it again. So for this one, when you add up these two together, 35, so 5 over 1 over 7. So yeah, correct, you get 1. Okay. So 1 times 4 over 7 plus 2 times 2 over 7 plus 3 times 4 over 35 and plus 4 times 1 over 35. So for everything, you times them together and add it up, you should be able to get 8 over 5. Okay? So remember for this answer, right, it's not the expected third one because you see your outcome is at 1, 2, 3, 4. How can it be like the expectation for the mean you expect to use 8 over 5 tower? So it cannot be like something that most likely happen. It's just like a theoretical mean. Okay? Because how do you count like 1.6 tower? Alright, so this is not like the most likely event to happen. It's just like a mean, a theoretical mean. Okay, so B, you want to find the variance for x. So same thing, formula, sum of x squared times p minus the mean. Okay, so x squared times 4 over 7 plus 2 squared times 2 over 7 plus 3 squared times 4 over 35 plus 4 squared times 1 over 35. So divide by the whole thing. Sorry, minus by the whole mean square. Okay, then you add it up together. 16 over 5 minus 8 over 5 square equals to 16 over 25. So that is your variance. Alright, okay, so I think it should be like quite easy for you for today's lesson, and today's lesson will be like quite short also for the example and so on. So it's just like basically an add up for the thing that you actually learn on Wednesday. Okay, so for the next chapter we'll be continue on is in this chapter. Yeah, there's like 3 learning outcome for this chapter, but in this lesson for this week we are going to cover up the first one first, because I think we can try to go a little bit slower now. Okay, then after that we are trying to learn like 2 distribution, which is binomial and geometric under discrete random variable. Okay, so that's it for today's lesson. So yeah, enjoy your weekend and take care.